IVM.
There's a quick survey to fill out on ivmpodcast.com/survey. It lets us know a little bit more about who's listening to us. And you know what? We're going to do a few prizes. So, we'll do a random drawing of maybe 10 people and we'll send you all some swag. Remember, that's ivmpodcast.com/survey where you can fill out the survey.
Welcome to All Things Policy, a daily podcast supported by Pragati, a flagship media initiative of the Takshashila Institution. We're a bunch of policy nerds based in Bengaluru, and we like to bring a fresh perspective to Indian affairs and an Indian perspective to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hello, welcome to a brand new episode of All Things Policy. I'm Megha Pardhi, and today we're discussing advanced computing age and India's position in this age. So advanced computing generally refers to high-end development of computing and processing capabilities to solve very complex problems and to be used in high-performance computing applications like supercomputers. So these days, computing power has become key determinant in many advanced computing mechanisms and scientific applications. For example, quantum and cloud computing, then digitization of national infrastructure, just few of the examples. So given how important this is going to be in this information age, many nation states are vying to increase their computing capacity and also for various strategic reasons. My colleague Arjun Gargeays has recently co-authored a discussion document along with Siddharth Bannerjee, which outlines a background to India's position in advanced computing age. To discuss more about this topic, we have Arjun with us today. Welcome, Arjun.
Hey, Megha, good to be here.
So, Arjun, before we start and dive into computing and India's position, I was just curious, what was your inspiration behind writing this paper? And also tell us how you made your co-author.
So basically, the whole concept behind computing, right? It's just a very simple thing when you think about it. It's just saying that, you need better processors, better devices to run your simulations faster or do anything faster, right? But then you think about it and say, why are people doing it? Why do everyone want to achieve this kind of superiority in doing everything faster and better with more accuracy, with less error rates? And why are nations and states especially going so far ahead in the sense that they're willing to invest so much money, so much resources in building these systems, which they can claim that they have the fastest computer in the world, or they can claim that they have the fastest quantum computer in the world. So why would they do that is one question I just wanted to understand, because I get the whole point behind computing power and the need for increasing it, because especially as you said, right, in the information age, with more and more data being generated each day and on a scale that we can never imagine, there has to be some sort of mechanism to process and use this data more efficiently. And this is where computing comes into the picture. But how does this relate to kind of national power, and how does this relate to having a more nuanced view on geopolitical and geoeconomic consequences of this itself? And that is what I wanted to explore. And incidentally, my co-author, he had worked in the UK government, and he had also kind of worked on the United Kingdom strategy to kind of facilitate the building of these advanced computing systems itself. So he said, I think we should do it for India and see what India is doing and how we can kind of ensure that India's position in this space hasn't gone to an extent where we cannot come back or we cannot make it better. And so we just started looking into these things, and then we realized that this has more than it offers, in the sense that it's not just nation states, it's more or less even private companies, including these tech giants, like IBM, Google, Microsoft, who are all vying for superiority in the field. And that is when we realize that this is not just going to be a normal thing wherein we say that it's just building of computers and systems that will help people, or that will help governments itself, but it's more or less like this high stakes game wherein the what is the better computer you build, or what is the better processor you have, what is the better system you possess. This the different applications of these computing systems then came into the picture, and that is when we said, okay, this has to be something that should be of national importance, in the sense that in at least the technology domain, if not many people focus on this, then it might kind of go unnoticed, and that is why we just wanted to write something about it.
So, Arjun, you're trying to tell me that the more computing power does not just mean that I get to play better video games. It also means that it's very, very important for our national and strategic applications, right?
Yeah, definitely. I mean, you can play better video games. That's always going to be there. But I guess it's more or less from a strategic perspective. Then yes, we do need better systems to handle the data that the country as a whole produces every day, or even every single hour. So and this cannot be just in the form of like these small scale computers which the government uses now. And imagine, like, this is just a scenario, right? You have a public health database, and on the scale of India, you have so many people, you have so many villages involved. And how do you kind of build that capacity to have this kind of computing power to actually maintain that kind of data? And let's look at it from like a military aspect, right? So you get military intelligence every single day, and this might be in the form of any kind of data, from audio to visual to anything. So having a better system to process this and get more information out of it is always going to be an advantage for the military, and especially in the strategic realm. And that is always going to be be an advantage. And the fact that these kind of systems help to do exactly that, in the sense they do it at a faster rate, they do it at a lesser cost, in the sense over a period of time, the more you utilize these systems, then the cost per operation gets lesser. And also the fact that they do it at a better rate, wherein better error rate, wherein you have less chances of losing information due to noise or anything like that. It processes data better, faster, and at a cheaper way.
Yeah, I mean, military applications of computing is something which I have also been reading upon, and as interesting as it seems, it's also, I think, perhaps one of the most advanced type of, or probably category of computing technologies. So, Arjun, can you just, just for me and my listeners, can you explain a bit about the major advanced computing technologies which I have been either developed or are being in process of development?
Yeah, I mean, there are a few, right? And I'm pretty sure most of the listeners would have heard about it, but I'll just do it either way. So, the first form of advanced computing was basically high performance. This was what we called HPCs, or high performance computing, and the solutions of high performance computings were a different range, and one of them was what was coined as the supercomputer, and the first ever one was built all the way back in 1964 actually. And since then many more have been built. And there was the first ever government and academia funded partnership in 1985 between the National Science Foundation of the US government, and they kind of built 5 research centers for building these supercomputers. And now it's just the fact that a lot of supercomputers are there across the world. It's spread out, and almost every country has their own. And each of them have their own kind of scale, and the computing power itself, like how fast they can do it. How it's called exaflop, teraflop, petaflop. This is what what we mean by saying, oh, this computer can do 10 to the power of 12 operations per second. This computer can do 10 to the power of 15 operations per second. So those kind of power differences still exist between these different kind of supercomputers. And it's just the fact that a supercomputer is just a solution for high performance computing. And how kind of you get that is something we can get by what we call as parallel processing and multi-core. So we know that the number of cores in a processor, like a CPU or a GPU, which are basically your processing units in a computer, has increased over time. It started off with just a single core, and then now it's dual, quad, octa, and these kind of systems have a lot more cores. And when you have those many cores, what happens is you can run simultaneous processes what across different cores, known as parallel processing. So that is when you kind of run parallel threads across different cores, and you kind of then bring it all together and ensure that computing is done, or the final operation is done, bringing all the processes together at the end. So what happens in a supercomputer is when like different cores are made into a node, and this is what we call as the HPC node, and each node forms like a cluster. So like there will be a server which is in place, which handles all the data. It basically fetches and gives back the data, and these nodes or the HPC clusters which are present will kind of ensure that computation takes place and send it back as soon as possible. So the main thing is the interconnectedness between the processor itself, the network storage, which is basically the memory, and also the fact that there are key algorithms, software algorithms, which are running on these cores and these HPC clusters, which are tailored to kind of supercomputing aspects, and they kind of help in faster computation. So, as I said, right, so this is mainly the fact of speed, cost, and simulation. So, speed in the sense more faster operations at and in a better time frame, and cost, initial cost would be actually high to build systems like this, but when once you kind of continue to do operations at the level, like you would kind of decrease your cost over time. And also in the fact of simulations, that's one of the main reasons why people are trying to build these computers, is because the need to do physical testing kind of has died down due to these, because they can simulate kind of anything, like in terms of the military, it can be military operations and warfare, or in terms of health, it can be molecular modeling and checking how it can actually fit into a certain drug or something like that. So when you kind of have these the capability to simulate these kind of processes, that time you completely ensure that you don't have to physically test it again after the whole system is built. So you kind of have reduced your effort and getting better results and better error rate. So you are doing it at a better efficiency and doing it more effectively. So that is what we call as high performance. And the second one, I'm pretty sure everyone would have heard of it. It's basically quantum computing. It which uses quantum physics and the concept of quantum information science. We already talked about this multiple times, but anyway, so it works on the concept of what we call qubits. How we have digital bits in computers which store ones or zeros. Qubits are these bits which are basically also called quantum bits, which work on the principle of superposition and quantum physics, that basically say that it can hold any value between 0 and 1 at a point of time. So that means that it has the possibility of holding more data and doing more operations at the same time compared to a digital bit itself. So it can help in optimization, search, and solving problems at an extremely quick space. So that is the concept behind a quantum computer. And there are different kind of quantum computing technologies which are being used to, like create these qubits. So there is the concept of using superconductors, there's the concept of using photonics, and also silicon, even what we call NV, that's the neutral kind of neutral atoms, and NV diamonds, and all these kind of things are just different technologies which are being used to create these qubits and build these quantum computers. So till now, there have been a lot of research happening in academia and private sector also, but it hasn't reached to a point where there has been a deployment of these systems in tackling large scale issues like real time issues or real time operations. So that is something that we would look forward to in the coming decade, wherein how these quantum computers can be deployed on an effective basis. So that would be the second, like those two are the main advanced computing mechanisms which are currently in use. There's also other stuff like cloud, and cloud is something that we all use. It's just where you have a single kind of data, like it's a centralized form of data storage, wherein it allows you to kind of store data on the cloud, and you can always fetch it faster. And it has also risen to kind of what we call as edge computing, wherein instead of the centralized form of data storage, you kind of have a personalized cloud on your own device, wherein you can store data, and when you have to kind of have to use that data, you can fetch and process data at a faster rate. So cloud computing has become a very again commercialized thing, with different data centers coming up, like Amazon Web Services, Microsoft Azure, and all these different companies who are basically making a lot of money on these data centers. Yeah, I mean, there's also other stuff like neuromorphic computing, which is something very unique, wherein they've tried to model the whole concept of a computer based on your brain, wherein neurons are kind of like electronically created, in the sense that circuits using electronic components are created, which are modeled based on the way your neurons function with your brain and the whole nervous system. So there have been a few companies who are involved in neuromorphic computing as well, like Intel and others, which who have actually kind of created their own chips and their own systems as well. And even like there's one which has partnered with the United States Air Force, which has created a neuromorphic computer for military applications as well. So, I mean, these are just the basic ones, but I'm pretty sure there will be more. So, there are quite a few.
Okay, so to sum it up, we have like four important applications of advanced computing. So first is high performance computing, then there is quantum computing, then there is cloud computing, and neuromorphic computing, right?
Yeah, I mean that was what we focused on, but I'm sure, like, because each of them are at their own area or at their own pace of development. So in the next decade, we could see one of them take the lead, one of them fall back. So you never know how this will play out.
Yeah, so this reminds me of, and again, let me take this opportunity to, quietly introduce China in this whole discussion. So this reminds me of this initiative which Chinese government has launched. It's called National Computing Infrastructure. And the high performance computing, when you explained it, kind of, and also with cloud computing, it reminded me very much of that. I mean, they're trying to build computing clusters. And we have also talked about this in one of our episodes, by the way.
Yes.
How they're trying to kind of distribute their computing and aggregate all this computing power. Yeah, so with this, we'll take a little break and we'll come back and continue our discussion.
Hey, it's been another great week on the IVM Podcast Network. On The Habit Coach, Ashton talks to Avantika Sinha, managing partner, leadership trainer, and coach at Stillwater Consulting. She shares 5 key mindsets that we all must imbibe in ourselves. The Simplified Gang look into the European Union's recent regulations to rein in tech companies. On the Filter Coffee podcast, Karthik speaks with author Vasanthi about her new book, Ganga's Choice. On the Life Manifesto, Zarina decodes 7 overrated concepts that we must do away with. And on Football Twaddle, Saru and Yash discuss how Arsenal always disappoints in the season. Do follow us on social media. We're IVM Podcast on Twitter, Facebook, Instagram, and LinkedIn. And remember, if you're enjoying this show or any of our other shows for that matter, please do tell a friend. Also, please don't forget to rate us on any of the platforms you're listening to us on. And remember, you can always check us out on YouTube. We have a number of channels. You can go to ivmpodcast.com/YouTube to take a look at what those channels are. We're also doing a small listener survey to understand how you respond to our shows and the advertising on the network. We would really appreciate it if you could spare a few minutes to fill it out. It really helps us build better shows for you and understand what you're looking for from advertising and what we can talk to advertisers about who you are. Please go to ivmpodcast.com/survey. It really would help us out. Thank you so much. And finally, would like to thank our sponsors for the network this week, SBI Life Insurance, India Water Portal, and Jupiter, a digital banking app. Thank you so much for making this possible.
Welcome back to All Things Policy. Today, Arjun and I are discussing advanced computing age and what will be the India's position and some background of India's position. So before the break, we talked about why computing power is necessary in current age and what are the major advanced computing technologies that are currently in picture. Now, Arjun, what's the current global landscape like in the advanced computing sector? And can you just briefly explain which states are involved and what they are doing about advanced computing?
Yeah, sure. I mean, that is what something we wanted to kind of focus on, in the sense that how much has this become a major factor in other countries, and especially in technologically advanced countries. And when we saw that, especially there's a list, it's called the top 500. It's the top countries with the number of the world's 500 most powerful supercomputers, right? So if you look at the distribution, China is the first. It took the lead in late 2020, and it has 173 out of the 500 top fastest supercomputers and most powerful ones. Second is obviously the US with 143. And these are just figures I'm quoting at the end of 2021. And there are more which are being developed, and this might soon change. But broadly, it's these two who have kind of dominated the whole landscape. And as you mentioned, right, like China has been focusing a lot on their computing power and the concept of distributing computing power across their mainland and having computing clusters across their territory itself. So this is the reason why they've kind of ensured that they've built more supercomputers and ensured that they're interconnected in a way that they can create a kind of grid like structure to utilize it better. And also the fact that Europe has focused on this field a lot, with Germany, France, and the UK all having around 20 odd fastest supercomputers in the world. So Europe is not far behind, in the sense that they have their own computing companies, like the French company Atos, which has a dedicated kind of division meant for the production of high performance computers and servers. And also there is what we call what they started, the Euro HPC project, which is the Euro High Performance Computing Project, which was kickstarted with the initial budget of around €1 billion. And this was mainly started by around 7 major European states: Germany, France, Spain, Italy, Greece, Portugal, Netherlands, and Sweden. Now includes Switzerland as well. It kind of wanted to ensure the building of these supercomputers across Europe, and so that it would be better to manage the data which was being generated. And also there was this whole concept of European Processor Initiative, which is the EPI, that was also created between a few European Union states. And this was mainly to create or develop these processors to be used in these high performance servers itself. So essentially it's been the US, China, and Europe, who have kind of dominated the field, especially in high performance computing, building these supercomputers and what we call as exascale computers. Exascale is when it's extreme computing power. So they're on their way, and China already has two exascale systems, and Europe is developing one. US already has one, and so these three major regions are where this whole concentration of computing programs has been like clustered around. So in terms of HPC, that one, and I think quantum, I'm pretty sure everyone would kind of have a clue about the fact that there's a lot of private sector involvement in quantum computing, like Microsoft, Google, IBM. And in terms of the private sector, most of these are from the US. So the US kind of had a lead initially, but now it's come to an extent wherein China owns the fastest quantum computers also, wherein they developed their own photonic quantum computer. Last year they unveiled it, and also they unveiled this Wangxi 2, which is the supposedly has the most qubits and is again the fastest quantum computer in the world. So in terms of both HPC and quantum, it's been the same players who are involved, in the sense it's US, China, and Europe also has like this whole quantum flagship initiative, wherein they've been developing national computing centers across different states, especially in the UK, wherein they want to do it by 2023. And Germany recently commissioned the construction of two new quantum computers, and France also has a major spender in developing quantum tech in like Paris Saclay and other private companies like Atos. So it's basically these three, right? So you can see that a lot of this has been clustered around this, but the fact is it's not just them. There are more people who are getting into the game, and you can see that through the fact that Japan has around 30 odd. Japan has a third most like fastest of the 500 supercomputers in the world. Even Korea, South Korea, and Russia and Canada, and so everyone has these systems now, and it's been a thing wherein it's more of a need that and a requirement than the fact that it's not just showboating anymore. It's not the fact that it's virtue signaling wherein it's saying I have these many number, because you need those many number of computing systems to actually tackle the kind of data processing and operations which like kind of happening in this information age.
Actually, this is a very good point, Arjun. That I mean, we often tend to see this, competition in technology domain, or the race to build better system as kind of virtue signaling that, hey, look, I'm the best. But it is also it's also mostly about trying to fulfill the needs of either entity or a country, because they need that much, so that they have to develop that much. Also, on a little side note, that I just wanted to explain exascale a bit. And exascale is super, 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 super fast computing. But to put it in numbers, it refers to a system where a computer system is capable of at least one exaflop. That means 10 to the power 18 calculations per second. So this was just for the listeners. Also, when you said that different countries are trying to develop a different system, that reminded me that China's 14th five-year plan also has some goals to develop, I think, around 10 exascale system capacity before 2025.
Wow. Okay. That's a lot, but I mean, of course, we've seen how ambitious the Chinese are, so you never count them out. So, yeah.
Yeah. Now it's time to talk about India. What has India been up to? Whole scenario.
India is this kind of new entrant, but also the fact that they have kind of realized the importance of these systems now. And it was in 2015 that the National Supercomputing Mission was announced, and it was the first step taken by the government in the field of high performance computing itself. So that is a jointly funded program between the Department of Science and Technology and the Ministry of Electronics and Information Tech. So that had a total outlay of around 4,500 crores, which is actually peanuts, for a period of 7 years. That was between 2016 and 2023, to develop these advanced supercomputers in the country. So basically, they had this vision of having three phases in the mission itself. The first phase, wherein supercomputers would be just assembled in India, and second phase, wherein it would be kind of designed in India, and the third one would be manufacturing in the country itself. So, with respect to the first phase, the second phase, the first and second phase basically ended by around September 2021, and in by February 2022, India currently has around 10 supercomputers which have been developed under this mission, and they have been housed at different research institutes across the country. There's one in IIT in BHU in Varanasi, ISER Pune, IIT Kharagpur, IIT Kanpur, and the most recent one in IISc Bangalore. So these kind of, this is the first official government policy towards supercomputing itself. But again, I was talking about the top 500 most powerful supercomputers in the world, right? So India owns 0.6% of that. So basically, 3 out of 500 fastest ones are in India. And these are not even like within the top 50. It's around 62, if I'm not wrong, and 70-ish, and one more in the 200s or something like that. So clearly, the speed shouldn't matter to an extent, but the fact that we are still behind developing these kind of such advanced computing systems that could compete with the ones in US or in China. So that there's still a long way to go, and the fact that now there have been calls about indigenously designing and manufacturing these supercomputers in the country. That is also a kind of a very a hit or miss kind of scenario, wherein these systems are not just one processor, one computer, so you just have to just build it and you can do it in like one month or 2 months or something like that. There are so many different components, so many different raw materials, so many different systems which need to be kind of brought together to form it. And no country, let alone India, can do this on its own, in the sense that you can't manufacture indigenously everything. So that's where you rely on tech imports, and that is something which India has kind of fallen back on, in the sense that they've consistently kept high import tariffs and all that. So that might be a roadblock for actually achieving this kind of advanced computing methods itself. So as far as the government is concerned, the supercomputing mission is something that has to be appreciated, in the fact that there have been calls for creating a national computing grid in the country, and this was the way to do it. But it's been around 7 years now since the mission was announced, and though there have been some kind of movement forward, there has to be more, in the sense that self-sufficiency and indigenous manufacturing would be kind of a hindrance, more of a hindrance rather than a boost to the mission. So that's with respect to high performance. But with respect to quantum, I think India has kind of just relied on private sector involvement, because there has been no official government policy towards quantum computing specifically. There has been the NMQTA, which is the National Mission on Quantum Tech and Applications, which is basically trying to build the entire quantum system. But there has been no kind of program specifically dedicated towards building a quantum computer in the country. And it has always kind of relied on private sector involvement. So 2021 kind of was a landmark year for India in terms of in this field, because MeitY, the Ministry of Electronics and Information Tech, they announced a tie-up with Amazon. It's basically the Amazon Web Services, to set up the country's first ever quantum computing lab, which was called as the Quantum Computing Applications Laboratory. And that was basically meant to provide access for developing quantum computing applications and building small scale quantum computers for both the industrial and the academic communities. And also, the IBM India has partnered with the government to create what is called as the Quantum Educator Program in the country, which is basically a collaboration between the company and top scientific institutions, education institutions like IITs. This is basically for upskilling in the field of quantum computing, because this is not something that anyone can do, right? So it needs a lot of human capital, and not in terms of the sheer numbers, but in terms of the quality of knowledge each person has in the field. So you need a highly dedicated kind of human resource allocation for quantum computing, and you need to have like a vibrant community across the country who can kind of build on these technologies and eventually build India's own quantum computer. So other than that, there has been one thing which is kind of caught my attention. It's a tie-up between a research firm called Ingores and the state government of Gujarat. They wanted to create the country's first ever quantum tech park. It's called the Greater Karnavati Quantum Computing Technology Park, which kind of wants to house the first ever quantum computer in India. And it wants to be like a tech park dedicated for collaboration between corporates and startups which are involved in quantum computing research and development. That was something very interesting to me, and I want to see where that goes, because that would actually help a lot in kind of getting together different actors who are involved and different stakeholders who are involved in this field. So that was something very interesting. Other than that, there are startups who are working in the field like Unilabs and Automatsky. So all of them have their own way of functioning, and they have their own applications which are being developed for specifically for quantum computing. So in that sense, I think that India has kind of recognized the need for this field, but hasn't kind of gone to an extent where they've poured in so many resources to advance this at a rapid pace. And it's going slowly, and with the level of technological innovation currently, by the time we reach at least 50% of what, let's say, the US or China, there would be a lot more gap between us and the West or even China.
Wow. I mean, this was very, very interesting actually to hear about what India is doing. And again, I'm a sucker for stories probably, but this reminds me of how India got its first supercomputer. And it's an interesting story actually. So I think in 1980s, India requested a supercomputer with United States, and US denied it, saying that that can be used for weapons development. And then India woke up to the possibility that this, kind of peak technology is getting denied. So we kind of combined the resources and built our own supercomputer. So when in 1991, Param was launched, I think one of the newspapers in US, I think in some Western country, had this headline that India's denied supercomputer, so angry India does it. And, Raghunath Mashelkar, eminent scientist from India, he had come to our college, and when he narrated this story, he said that if angry India could do it at that time, why India does not get angry every day. I mean, we have to be angry to build cutting edge technology. So we need to be angry, and that was interesting.
Exactly. Yeah, I mean that I kind of didn't know that story, in the sense I knew that that we had requested the US, but the fact that this kind of development happened way back in the 90s shouldn't deter us now, because we have already reached a phase wherein we are one of the most technological advanced countries in the world, and there should be nothing to stop us, especially not money and human resources, because we have both. So hopefully we can combine both to ensure that we do not fall way behind the pack.
Yeah. So this was a very interesting session, Arjun. Thank you so much for joining. And thank you so much for this wonderful, wonderful paper and what you have done. It was a very interesting read. I hope everybody else enjoys this as much as I did. Thanks again.
Thanks, Megha. Always a pleasure. Cool.
Bye.
See you then. Bye-bye.
If you liked our show, don't forget to check out other interesting podcasts on the IVM network. You can tune into them on the IVM Podcast app, ivmpodcast.com, or wherever you listen to your podcasts. You can also follow IVM on social media. The handle is @IVM Podcasts on Twitter, Facebook, and Instagram. And hey, if you'd like to dive into Takshashila's research on technology, strategy, and economic affairs, check us out at our Twitter handle @TakshashilaINST or our website takshashila.org.in.
Do you find yourself in a room full of people talking about investments and insurances and feel left out? Do you also want to understand how to spend your money wisely? Then you have come to the right place. Welcome to SBI Life Presents A Sip of Finance, a women-exclusive podcast where we break down difficult financial topics into simple and straightforward episodes with your host, Priyanka Acharya, a finance expert who's been in the industry for 14 plus years. And not just in English, but in 7 more languages. So tune in every Tuesday for fresh episodes on the IVM Podcast Network and all major podcast streaming platforms.
You're the people pleaser, right? Or then desperately seeking the one? Or wait, you're the one who doesn't think they're ever good enough. So much drama. And for what? Is it doing you any good? Listen to me. I'm Chetna, your favorite positive action coach. Yes, I'm the one who has been dropping all those truth bombs on every episode. Oh, no. And it's time you learn to say no to drama. That's also what my podcast is called. And a new episode is out every Monday and Wednesday on the IVM Podcast app, website, as well as all major podcasting platforms.